everyone. Welcome to our next video lesson on sequences. We're going to take a step back from the exponential growth and decay functions that we've been working with for a minute, but they are going to come back into play. And today I just want to go through a very basic introduction as to what a sequence is, how we recognize them, and what we can do with them before we get into more specific patterns and formulas. So hopefully today seems rather simple and straightforward, but it is very important for our next few lessons. So if you have any questions that come up, feel free to reach out to me as you do this on Remind or when you submit your notes on Google Classroom. But right now you need a notebook, something to write with, and a calculator, and let's go ahead and get started. The first thing I want you to do is to copy down the 5 lists that I have here. And like it says up top, can you spot the pattern? Each one of these has a specific pattern to them, and it will help you lead to the follow-up question, which is what comes next. So take a second to pause the video, copy them down, and see if you can guess how to fill in the 3 blanks that come after each list. All right, so I know some people are probably going to feel a little stuck or confused as to what I'm asking, so I went ahead and finished the first 2 for you. Okay, in this list, I went from 1 to 3 and 3 to 5 and 5 to 7. If you take a second to think about it, what I'm doing is I'm adding 2 every single time. I've comprised a list of the odd numbers. So if I continue my list and I continue that pattern, I add 2 to get 9, add 2 to get 11, add 2 to get 13, and that's how I filled in my 3 blank spaces. In the next example, though, I couldn't add the same number going from 4 to 16 as I could from 16 to 64. So instead, I found a different pattern. Multiplying by 4 gets me from 4 to 16 and also gets me from 16 to 64. So I took 64, I multiplied it by 4, and I got 256. Multiply that by 4, you get 1024. Multiply that by 4, and you get 4096. So if you didn't last time, or if you felt confused, now pause the video. See if you can come up with the next 3 terms in each of these lists. All right, so how'd you do? Okay, in list C, I was multiplying by -1 every single time. Remember, you're trying to find one specific pattern. So every year I always have students that are like, well, can I just think of this as subtracting 10, then adding 10, then subtracting 10, then adding 10, and going back and forth? Yes, in the sense of a pattern that works, but mathematically we want to find the one thing we can carry through from every term to the next. Okay, so I was multiplying by -1 here. In this case, I was subtracting by 10 every single time, so -28, -38, and -48. E was an interesting pattern because it wasn't just one operation. In each of these steps, I was not only multiplying the number by 2, but then also adding 1 to the result. So I took 3 times 2 and got 6, plus 1, which gives me 7. 7 times 2 is 14, plus 1 gives me 15. So I continued that pattern, and it should be filled in with 31, 63, and 127. And the last one was definitely the most challenging and most unique sequence that I've seen. It's a famous sequence. It has its own name called the Fibonacci sequence. And what you do is you add up the 2 terms that come before the one you're looking for. So it starts off with 1, and since there's nothing before it, you just keep that 1. But then 1 plus 1 gives you the next term 2. 1 plus 2 gives you the next term 3. 2 plus 3 gives you the next term 5. 3 plus 5 gives you the next term 8, and so on and so forth. So 8 and 5 is 13, 13 and 8 is 21, 21 and 13 is 34, and that's how that sequence continues. So as you can see, these lists can follow one pattern using one operation. They can follow one pattern using multiple operations, and then sometimes there's a pattern that you can't even really mathematically write down, but they do have a specific order to them, and that's what we call a sequence. Okay, a sequence is an ordered list of elements, terms, or members, and about 99% of the time in your math career, they're just going to be an ordered list of numbers. The important thing to note, is that it is an ordered list. So whatever numbers you've been given in whatever list you've been given, they follow a specific order and you cannot move them out of that order. That's what makes a sequence different than a set. All right, so a finite sequence is one that is going to stop at some point. It's going to be a collection of numbers that only include the numbers in your list. And an infinite sequence continues on forever. So those are the ones where we're looking for a pattern so that we can predict the next few terms. And we note an infinite sequence by using these 3 dots at the end. Okay. You'll also notice in both of these examples, I have those curly brackets around my sequence. So those are going to come back to us if you haven't already mastered them. This is a great time to practice. But we saw these curly brackets when we were listing out a set. And we always said that the order didn't matter in a set because it was in curly brackets. Now the difference between a set and a sequence is that the order does matter here, and however it's listed, it needs to stay listed that particular way for any future way that you write it down. Okay, pause the video and copy down whatever you missed from this page if necessary. Okay, so the next thing I want to talk about in this video is the way that we note a sequence or the way that a sequence will be presented to you guys, and it's something called subscript notation. If you've ever been in a Google Doc or a Word program and you see the subscript option for font, what it does is it pulls whatever you have highlighted into the bottom right hand corner, and that's where a subscript is located. So it's kind of like an exponent where the exponent is in the top right. A subscript is going to be in the bottom right. And the reason that we do that is because mathematically it's a much quicker way to label all of our terms, and then we use that to set up our formulas as we move forward with these sequences. All right, so 90% of the time, especially in Algebra 1, you're going to be dealing with a sequence that has some sort of pattern to it, and we're going to use that pattern to our advantage. But I wanted to show you guys an example here that really has no pattern, rhyme, or reason. It's just quite literally a list of elements in some particular order. What order that is, I don't know, but it might have some meaning behind it that I wasn't given. All right, so when we use this subscript notation, I'm just going to explain to you guys where it comes from, and then I'll show you guys how it's going to be used in the next couple of lessons. All right, these terms are in a specific order, so if I ever wanted to talk about one particular term, I would label it in the order which it came. So this 8, I might label as the first term. Right? And then my 14 would be the second term. And the 15 would be the third term. And so on, right? I could label all of these numbers that I was given if I wanted to. Okay? But writing out first term, second term, third term, we all know that mathematicians are sometimes the laziest people, and we try to look for the most efficient ways to jot things down as quickly as possible. So writing out things like first term, second term, third term, that's too much. It's way too much time. So what they decided was, as a universal notation, the first term is going to be listed as A sub 1. Okay, so my A is a normal sized font. It's usually lowercase, but my 1 is small in the corner. It's at the bottom, and you'll notice that my 1 actually overlaps the line because it's supposed to be dragged as a subscript. Okay, so then the second term is going to be A sub 2, and the third term is going to be A sub 3, and A sub 4, A sub 5, A sub 6 would come next. Okay, so you'll notice that I'm picking numbers 1, 2, 3, 4, 5, 6. Those numbers are not only integers, they're known as our counting numbers, also known as our natural numbers. So I could sit here and I could continue to list out A sub 4, A sub 5, A sub 4, A sub 5, A sub 6, but for a sequence that continues on and on and on and on and on, you might have an infinite number of terms to label. So any unknown term that we haven't gotten to yet, okay, or the generic way to label a sequence is with the notation A sub n. Okay, because we're using natural numbers in these subscript spots, if you don't know specifically which term you're supposed to look at yet, you used an n as a variable to hold that place of that number you don't know yet. Okay, so sometimes the a will change. It's kind of like our f of x function. If I don't want to call it f of x, maybe I call it g of x or h of x. This could be a sub n or b sub n or q sub n, depending on what sort of details we have with the story. But in general, what we'll do is we will label the entire sequence with the general format a sub n, and then as we get more specific, we can label the terms as a sub 2, a sub 3, a sub 4, right? So I'm going to just draw a line, because what I'm going to write next really has nothing to do with this sequence up here. All right, but I'll give you another example. Sometimes these are x sub n, right? So if I want to label this sequence, this particular sequence, x sub n, and it's the set of numbers that goes 1, 5, 9, 13, and so on, okay? I can use this notation x sub n to label the entire sequence as a whole. So you'll see a sequence listed out like this a lot of the times. I can then be more specific and say x sub 1 is 1, x sub 2 is 5, x sub 3 is 9. And in the future, in our next couple of lessons, what we're going to get into is you'll actually be able to write an entire formula for the sequence that will help you find any term in the entire sequence. Now, this is not going to make sense to you guys because I haven't quite explained the math that got me here. All right, but this is a notation that you're going to see very frequently where I can come up with a specific formula that if I know which term I'm looking for, let's say I wanted to know the fifth term, the one that comes next. If I want to find x sub 5, then I just plug in 5 for n in both spots. And that's going to tell me that my next term, x sub 5, is going to be a 17, 20 minus 3. Okay, again, this will become a whole lot clearer in the next couple of lessons, but I wanted to show you guys where this a sub n, x sub n, where that subscript comes into play. Okay. And the last thing that we're going to do for today is just to get you guys comfortable with that notation. I have one more sequence for us to deal with. So I'm going to draw another line here. Didn't mean for that to get so close. Okay. And now I've given you guys the sequence b sub n. Okay. That is normally going to be an A. That's the most common letter, but it can be any letter. And this n is 99% of the time always going to be an N. So my sequence, which I'm calling b sub n, is made up of the numbers 4, 8, 16, 32, 64, 128, and continuing on forever and ever. Okay, so take a second, pause the video, copy down our sequence, maybe copy down our questions, and see if you can figure out what the pattern is for this sequence. Okay, now I'm going to start off really easy. Like I said, we're just going to get used to talking in this sort of way and using this kind of notation. In part A, if I want you to find b sub 5, what I'm asking here is what is the fifth term in the sequence we labeled with a b? So I'm literally going to come up here to my overall sequence. I'm going to count out 1, 2, 3, 4, 5, and the fifth term in my sequence is 64. Okay, try B. Find b sub 3. Okay, well, what's the third term in my sequence? 1, 2, 3. 16. Okay. Now, a slight twist on that kind of question is if I don't know what spot it's in, but I know I'm looking for the term 128, find the n value, find the spot in order that it is in my sequence. So if I was looking for the 128 in my sequence, I would go to here. Okay. If I want to know which spot it's in, which term it is, I would go 1, 2, 3, 4, 5, 6. So in this case, because I have a list to look at, it's as easy as counting. In the future, we'll figure out how to find those terms and n values with equations instead of lists. But right now, I want you guys to recognize that b sub a number means what's the value in that spot. The n itself that's in that sub spot is asking what position or what spot is that number in the sequence. Okay. The other thing to recognize with this notation is there's really never any math that's done with the notation b sub whatever, a sub whatever. It's like f of x, right? If I said f of 2, there's no math that we do in between the f and the 2. There's no multiplication there. There's no simplifying. There's no changing what that says. That's just a notation. Same thing here. B sub 7 squared is asking me to do something with the number that represents the 7th term in my sequence. So I'm not going to change anything about this because b sub 7 is nothing that I can do mathematically. What I have to do is I have to replace the b sub 7 with the 7th term in my sequence. Okay, now if I use my list 1, 2, 3, 4, 5, 6, 7, I wasn't given the 7th term. So how could they be asking me this question? And this goes back to, did you find the pattern of this sequence? Okay, to go from 4 to 8, 8 to 16, 16 to 32, and so on, there's one particular thing I can do every single time, and that's multiply by 2. So luckily, they're only asking me for b sub 7, which is the next term after this 128. So let's carry that pattern through. 128 times 2 would give me my 7th term of 256. So in order to answer this question, in order to actually do the squaring, I'm going to replace b sub 7 with its actual value, and then I'm going to be able to do the calculations. I'm going to raise my 256 to the second power. Whoa, 65,536. Okay. Same situation down here with E. It wants b sub 6 minus b sub 2, but I don't get to do any subtraction with the way that it's written here. Okay, these are not what we would consider like terms because these are not exponents. These are subscripts and they're just labels. So think of these like placeholders. I am going to eventually subtract, but I have to replace them with their values before I can do any operations. So let's find b sub 6. 1, 2, 3, 4, 5, 6. Oh yeah, we knew that b sub 6 was 128 when we found the answer here. So this is going to be replaced with a 128. B sub 2 would be the second term in my sequence, which is 8. And now I can do the math, 128 minus 8, which is 120. Okay. You guys will have practice with this, but like I said, let me know any questions that you have either through our Remind messaging or on Google Classroom when you submit your notes. Have a great day, everyone.